A cathode ray tube is the forerunner of the television tube. It is a glass tube from which most of the air has been evacuated. When the two metal plates are connected to a high voltage source, the negatively charged plate, called the cathode, emits...
So what they do here is they get a so they take a high voltage source, so some electrical source. So electricity was known at the time, but it really wasn't very well understood exactly what electricity was. You knew that it was dangerous if you had a high voltage, but this experiment was also an investigation of like what is actually electricity, how does it behave, can we break it down into what it's actually fundamentally made up of. So you have a battery or a high electrical source, a high voltage source. You connect one end of the battery to a plate and another end of the battery to another plate. So a battery or an electricity source is really just a situation where you have electrons that are really attracted to one side and you have an abundance of electrons on the other side, or the electrons on the other side aren't really strongly attracted to anything. Right? So this, at the time, it was well understood that positive charges and negative charges attract. There are experiments that show that that's true. And so it's known that if you have some negative charge and some positive charge, they would attract one another. So another way to think about this is just connect a battery with a negative end and a positive end to a couple wires and then connect them to these plates. So if you put enough electricity in that situation, if you create enough of an electrical potential here, then as the electrons or the negative charge is flowing onto this plate, it's attracted to this plate because the battery is pulling negative charge electrons away from this plate. So as you connect really anything to a battery, if you haven't really completed the circuit, a lot of positive charge will build up on one end and negative charge will build up on the other end. If you've ever taken like a 9-volt battery and you put it on your tongue, it gives you a shock, right? Because there are electrons building up on the negative end and there are areas on the positive end that have electrons that have evacuated or left that area. And when you connect that to your tongue, the electrons flow across your tongue and that gives you the sensation of an electrical shock. So this is going to be a much higher potential than that. Right? So with that 9-volt battery, you need your tongue to allow some medium for the charge to flow through. In this situation, though, we just have a vacuum, empty space here in between these two plates. So what's happening is the negative charge is being stripped off of this plate and pushed onto the other plate. And if you build up enough negative charge on the one side, on the cathode, building up negative charge on that side, even though there's nothing to transport that negative charge to the other side, if you build up enough charge and the negative charge on that side is starting to build up to the point where all those negative charges repel one another, then those negative charges will fly through space toward the other side because the other side is positive and they're attracted to the other side. So the idea here is if this second plate didn't have a hole in the center, then the negative charge would just flow from this side to that side. You have like an arc lamp. And you could see like a little lightning bolt, maybe it might give off light or it might not give off light. But those charges be building up here and they would just shoot over here because they're so strongly attracted to the other side. So the idea that was interesting about this experiment was they cut a hole in this plate. So now as the electrons are attracted, if they build up speed and momentum, when they hit that hole, instead of getting stuck to that plate, they might just pass straight through. Right? So that's what they did with the cathode
an invisible ray. The cathode ray is drawn to the positively charged plate, called the anode, where it passes through a hole and continues.
A hole in it, it would just pass right through that plate. And then over here they had a stream with some chemical on here that lights up when it gets excited or when energy hits it. So when those hit the screen, you can see where it's lighting up, and you have an idea, because you can't see these negatively charged electrons flying through the air. You only see where they land because the energy that they hit the screen with causes the screen to get excited and give off light. So what was your question?
Oh, you answered it. I had just asked how it all kind of worked out with that. I couldn't follow it.
Okay.
Video for a minute, but yeah.
Okay, yeah. So the idea here is you need some electricity source to build up charges on the plates. That's what causes the electrons to flow. So this was like the first experiment where they could show electrons existed, and they could characterize the properties of an electron, show that they have a negative charge, and show how much negative charge they have, and to show that they do have a small amount of mass, because they could pass right through that hole and hit the screen on the other side.
Well, why does it evaporate this glass tube?
Yeah, so why does the tube have to be under vacuum? So if you have air in here, air is made up of, it's not very dense, but it's made up of molecules, oxygen, nitrogen, and atoms like argon and such. Those atoms and molecules just make the experiment more complicated. Because if you have atoms and molecules in here, when the electrons hit those molecules, they might get connected to that molecule and join up with it instead of passing through. So what they wanted here was just something totally empty. So if they're seeing something happen, they know whatever's happening here when the screen lights up, it's not because of interactions between the electrons and air molecules or anything like that. It's just because of the electrons flying through empty space. There's no interference with anything else that might make it more complicated.